Hi and welcome everyone to this lesson in our course for solar energy. In this lesson, we will discuss the mounting of PV panels or PV system and the tilt angle of a PV panel. So first, what is the mounting of PV system? Simply mounting means we are installing our PV system in different ways. Okay, so we can install our PV system on the roof, for example, such as in our home. Okay, like this. This is the first type of mounting called the roof mounting. We have pole mounting on a pole here, as you can see, and we have ground mounting, which is used for large PV systems or mega PV systems. Now the roof mount, you will find that it is simple and cheap to install because you are just installing the PV panels on the roof itself. We don't have any flexibility in orientation of the PV system. What does this mean? It means that we don't have much control on the orientation of the PV system, the motion of the PV panels, as we will see in the next slides. It does only support a small PV system, such as in our home or in small houses, when we would like to provide electrical power to our home. Another type of mounting system, which is the integrated PV panels. The PV panels itself is integrated into the building itself. So as you can see, it is integrated on the roof, inside the glass itself, and here it is integrated on the face of the building, also on the glass of the building. So as you can see, these two types, if you remember, we said that there is a type of PV panels that is used in this type of installations. We said before that we use the thin film inside when space is not important for us. They give a good look and at the same time they have very low efficiency. So if you remember in the previous lessons, we said that the efficiency of the thin film efficiency is about 7%. Okay, if you remember. So it has very low efficiency. That's why we install large amount of this panels, and at the same time it is very cheap. Now let's discuss, since we talked about the mounting systems, we will need to talk about the tracking systems. So what does tracking mean? Okay, so if you look at the PV panel here, what we would like to do in order to produce the maximum power, the maximum power possible or maximum possible power. Okay, in order to do this, the sun rays should be perpendicular on the PV panels. So the sun rays itself should be perpendicular on the panels, all forming 90 degrees with the surface of the panel. Okay, so as you know that the sun itself is moving through the whole day. Okay, it is moving through the whole day and moving also through the different seasons. So we can use something which is called the tracking system in order to change the orientation or change the angle of this PV panel so that it will always track the sun to produce the maximum power. So as an example, at noon here, you will find that we have sunlight directly on the panels. Then at morning position, we turn the panels to the right in order to face the sun, and at evening we turn it to the left to face the sun. Okay, so if you keep the panel in one position or one orientation, you will find that, for example, in this case, you'll find that the sun rays are falling like this, which are not perpendicular, and here are not perpendicular. However, when we change the orientation of the panel with the movement of the sun, we will able to get the maximum power possible. As you can see, here is an PV panels. You can see it is moving throughout the day. And here this also moves like this one. Okay. Now, how does this PV panels move? They move using an electric motor. So here, this system is called the solar tracker. So the solar tracker is a device that is used for orienting the PV cell or the PV panels toward the sun. How does it do this? Using light sensors connected with motor. So this light sensors sense the light, and according to the signal coming from it, it will cause the motor to operate and causes the orientation or changing the position of this PV panel. Now, why do we use a system like this? Because it will help to increase the efficiency or the total power produced, okay, or the total energy produced by 15% in winter and 30% in summer. Okay, remember, this is not the efficiency of the conversion of the panel. Remember, we had monocrystalline, polycrystalline. Each one has its own efficiency. However, 15% here, when we are comparing with the output power without tracker and without, and power with tracker, solar tracker, you will find that this power is higher than this power by 15% in winter and approximately 30% in summer. Okay, so that's why you can use the tracking system. However, this type of systems is expensive, or because you have here a motor and light sensors. So as you can see, it will lead to increasing the cost of the solar energy system. Now, what are the different types of the solar tracker or the tracking systems? You'll find that we have two types. First one is a single axis tracker, which can be vertical or horizontal, like this one. You can see this is a single axis. What does this mean? It means that it moves along the vertical axis or along the horizontal axis. So you can see that this type, for example, it moves like this, up and down. Okay, up and down. Okay, so up and down, it moves along the vertical axis. Okay, up and down. Okay, so it can be like this, it can be like in this position, or it can be like this, or it can be like this. So it is moving in the vertical axis. Okay, other type, which is the horizontal, which is moving like this and like this. Okay, so it can be sometimes like this, other time it will be like this, other time will be like this. Okay, you will see a video now which will shows this types of tracking systems. Second one, which is a dual axis tracker, which have both vertical and horizontal axis. So you can see here, this one, which is a dual axis, it means that it rotates in the vertical and horizontal. You can see it can rotate like this and like this, and same time it can rotate up and down, okay, in all of the directions. So of course the dual axis is much better. However, it means that we have more cost, or it is more expensive than the single axis. Okay, usually you will have to understand that usually in a small PV system, such as in our home, we don't use any types of trackers. We use the fixed oriented or the fixed PV panels, which does not move. So if you look at here, you can see this PV panel is moving. You can see it is moving in both axes, rotating towards the sun. Okay, like this, as you can see here. Okay, you can see it can be vertical, or it can be horizontal, or it can be something like this, which is a dual axis. You can see the PV panel is always tracking sun, going everywhere in order to absorb the maximum power. Okay, so before we discuss something which is important, which is tilt angle, we have something which is called the air mass. Okay, so what does air mass mean? Air mass is simply the proportion of the atmosphere that the light must pass through before striking the earth relative to its overhead path length, and it is equal to y over x. Now what does this even mean? Okay, so as you can see here, we have our atmosphere here, the earth's atmosphere. Okay, now you can see we have this, for example, is our location here. Okay, now this is our sun. Okay, so before reaching the atmosphere, the AM is equal to 0. Okay, because there is no distance. Okay, so AM here, or air mass, is equal to 0. However, when we are directly above the location, the air mass is equal to 1. Okay, which is the distance when the sun is perpendicular to the location. Okay, directly on it. Now, if the sun have an angle, a certain angle away from the vertical position, you will find that we have here sun rays. Okay, sun rays like this. You can see this distance is now different from this one. Okay, so if you look at this figure, this will help you understand. You can see there is a direct space from the atmosphere to the location. This perpendicular position is called x, or when AM, or the air mass, will be equal to 1. Okay, so the air mass here is equal to 1. Now when the sun forms an angle, okay, it moves like this, it will lead to a larger distance called y, which is this one. Okay, now you can see that there is an angle between the vertical position or the perpendicular position and any other position. Now this angle, when this angle equal to 48.2, we will have AM, or the air mass, equal to 1.5. So simply, what does the air mass mean? Okay, so air mass is the ratio between y over x. You can see y over x. Now if you look at this figure, you can say that here we have 90 degrees. Okay, 90 degrees. So this is considered as the hypotenuse, and this one is considered as the adjacent. Okay, so if we know from mathematics, cosine theta, or trigonometry, cosine theta is equal to x over y, x over y. Okay, now y here, so this will be equal to, okay, x over y. Now as we said now, that air mass is the ratio between this distance y over the vertical distance x. So this will be air mass. Okay, so x over y is 1 over air mass. So from here you can find that air mass is equal to 1 over cosine theta. So 1 divided by cosine this angle will give us the air mass. So usually the standard value, which you will find in PV panels, standard values at which we are taking our measurement, or the standard conditions, are at air mass equal 1.5. So when air mass 1.5, this is the standard values. Okay, so what does this mean? It means that the angle theta will be equal to 48.2. 48.2. Okay, so you can see angle 48.2. So 1 over cosine this angle will give us 1.5 air mass. So when you see on the panel that the air mass, the measurements are taking taken at air mass of 1.5, it means that the angle between the vertical distance and the current position of the sun is 48.2. Okay, this is what does it mean. Does it really matter in anything? No, it doesn't matter anything. Okay, this is just for your own knowledge. So when you see air mass 1.5, you understand what does this mean. Okay. Now, if you look at any waveform like this, very large waveform, for example, this one, 2245 megawatt, which is 2.2 gigawatt. This is in India. You can see a large waveform, and you can see between these panels, you have one row, then a next row, then a next one, rows. You can consider each row as one string. Okay, you can assume this, that each row representing one string. Okay, now you can see that there is a distance between them, between here and here. Between each row and the next one, there is a distance. Okay, so if you look at another one here in United Emirates, you will find that also here, if you look, we have a row of panels here, then the next one, and between them a distance. Okay, if you look at this PV panel, there is a distance between them. Also, this is a farm in Japan. Okay, now this will lead us to something which is called the tilt angle and the distance between two panels. So as you can see here, that the tilt angle of a photovoltaic or a PV array, or usually they all have the same angle, usually. So the tilt angle of a PV array is the key to an optimum energy yield. Now, why is this? Because if you look at any panel like this one, we have an angle called the tilt angle. Where is the tilt angle exactly? It is the angle between the panel itself and the horizontal line. You can see this horizontal line here. The angle between the panel and the horizontal line is called the tilt angle. Now, why is this important? Because this angle, why is this angle important? Because we are trying to make the rays of sunlight to be perpendicular on the panel, 90 degrees on the panel. Why? In order to yield the maximum power or harvest the maximum power. Okay. So how can we determine this angle? We will learn how to do this in the next slides. So you have to know that solar panels or PV arrays are most efficient when they are perpendicular to the sun rays. Now there is a problem here, is that if you look at a panel like this, when it has a certain angle beta, which is a tilt angle. Now, for example, if I install the next one like this, next panel like this, you will see what? You will see that this panel is causing a shadow on this panel, which means it reduces the electricity generated from this panel. Okay, this phenomena is called the self-shading. So self-shading is simply that each panel is producing shadow behind it. So you can see sun rays here forming a shadow at this region. Okay, so if we install a panel directly before it, it will be having a shading effect. Okay, so what are we going to do? Simply we are going to provide distance between each row. So we provide distance between rows to prevent the self-shading. So if you get back here, that's what I'm talking about. You can see that this panel is slightly inclined from the ground or the horizontal line by the tilt angle. Okay, so we provide distance between these two rows. Why? In order to prevent the shadow of this row from coming on this panel. Okay, so we provide distance to prevent the self-shading effect. Okay, so what is the distance required? The distance should be at least 3 times the width of the panel. You know that any panel has not like this. Let's type it another way. Any panel is like this. Okay, installed like this, the width of the panel. Okay, so you can see that this panel has a width called W. Okay, so in order to between each row, we will add what? We will add a distance D, which is equal to 3 times the width. So for example, if this width is let's say 1 meter, for example, then the distance between each row D will be equal to 3 times W, which will be equal to 3 multiplied by 1 meter of the panel, which is 3 meters. Okay, distance between panels. Okay, now how can we obtain the tilt angle? Okay, so you will find that if you search for tilt angle, how can you determine it? You will find lots of methods to get the tilt angle, and each method actually give us different values. Okay, so there is no one correct solution. Okay, so here this is a tilt angle between the panel itself and the horizontal. When this tilt angle is equal to 0, it means that this panel will be like this on the horizontal line exactly. Okay, so here this is a standard roof angles between it and the ground. The roofs itself in Australia, okay, 15 degree and 22.5 degrees. So sometimes you can to control it, the panels itself is installed on the roofs with the same angle of the roof itself. Okay, you can just install it directly above the roof. Okay, you don't have any control on this. And in other times, such as on the ground, you can control this angle. Okay, so let's say you control this angle and you would like to know what is its value. So here is a beautiful map which gives us an approximated method. Okay, so here for different regions in the world, depending on your own location, you will select the optimum angle. So as an example, which I'm going to show, for example, here in Egypt, here you will find that the angle, the optimum angle, optimal installation angle for tilt angle is between 26 degrees and 37 degrees. In this range is an optimum angle. Now, why it is a range? Why it is not just one value? It is a range because this angle, it changes through the day. It changes from one season to another. Okay, so there is no one fixed solution. Okay, so this is a range which can help you. You can select an angle in this range. This is just an overall or an overview about the tilt angle. Okay, so here to give you a point of reference, a 0 tilt angle. So here you have 15 degrees, okay, between it and the ground. So 0 degrees, 0 tilt angle means that the panel is lying flat down on its back, facing directly upwards. So it will be like this, like this. So it's facing upwards. Okay, so as the inclination increases, the panel would be adjusted to face more and more to the front. Okay, so as you can see, when we increase this angle, it is more to the front, more to the front. So as you can see, it is like this. Increasing the inclination means like this, and so on. Okay, that's what does this mean. So you have to understand that there are many other ways to get the tilt angle. So how can we do this? As an example, the first method, I will give you some methods and I'm going to show you in the next lesson an example on this. Okay, so here the first method is that you go to this website of NASA in order to find the latitude of your own place. Let's say you already know the latitude of your own place. Then what is the next step? Simply, if your own latitude of your own location is between 0 and up to 25 degrees, then the tilt angle will be equal to, so theta or beta, or the tilt angle will be equal to what? The latitude itself, the latitude L multiplied by 0.87. Just like this, very simple. Okay, simply take latitude and multiply it by 0.87. Second way is that you can say that if you have the latitude between, if your own latitude of the location between 25 and 50 degrees, then what are you going to do? You will find that theta in this case will be latitude multiplied by 0.87, L multiplied by 0.87. After that, you will add 3 point degrees. So you will say plus 3.1 degrees. Okay. Now, if your own latitude is above 50 degrees, then the most ideal angle is at 45 degrees. You will set it at 45 degrees. Okay. Now, this method is used for a fixed oriented panels. You are saying that I am going to put the panels in a fixed location throughout the year. So these formulas will give you the best angle to install your own PV panel. Okay. Now another method which you can get. Now let's say you can change the orientation of your own angle, or you have a tracking system. So what I am going to do in this case you will go to this website. This website will give you the solar angle during the year. So you can for each month you will have the best angle. Okay. So when you go here, as we will see in the next lesson, you are going to select the angle or the best angle in each month of the year. Now the final method, or before final method, you can use this calculator to get the angle. This is also another website which you can put your own location and it will give you the angle. We will see this also in the next lesson. Finally, you will find that another approximate method, and many solar engineers use this method, is that they say that the tilt angle is equal to the latitude of the location. So if you're having a latitude of the location is 30 degrees, then the tilt angle, or the ideal tilt angle, will be 30 degrees. This is the easiest method and the most approximated method that is used. Okay, so you can see we have how many methods? We have one method, we have 2, 3, and 4 methods. So let's see in the next lesson by using this what will be the tilt angle in this location. Okay.